Have you ever wondered how you can walk through your house in the dark or instantly recall where you left your keys? These everyday feats seem effortless, but they rely on a remarkable brain system known as cognitive mapping. Cognitive maps are mental blueprints that help us navigate our surroundings and remember locations without conscious thought. This system works quietly in the background, supporting everything from finding your way in a new city to recalling where a memorable event took place. The close connection between spatial awareness and memory means that our brains are constantly tracking where we are and where we've been, even when we're not actively thinking about it. As we move through life, these internal maps are always at work, guiding us and shaping our experiences. Cognitive maps are more than just a mental list of places. They are flexible, internal representations of our environment, allowing us to understand how different locations relate to each other. Instead of memorizing every detail, our brains create simplified maps that can be updated as we explore or as our surroundings change. This ability lets us plan shortcuts, remember routes, and adapt quickly when faced with new environments. The process is so efficient that we often don't realize it's happening. Whether you're navigating your daily commute or recalling the layout of your childhood home, cognitive maps are at the core of these experiences, making spatial memory and navigation feel second nature. At the heart of our cognitive mapping abilities lies the hippocampus, a critical brain structure for both navigation and memory. Within the hippocampus, specialized neurons called place cells become active when we are in specific locations, essentially marking our position on an internal map. As we move, these cells update, allowing us to track our journey and remember important places. The hippocampus doesn't work alone. It collaborates with other brain regions to create a seamless navigation system. Damage to this area can lead to difficulties in both forming new memories and finding one's way, highlighting just how essential the hippocampus is for our daily functioning and sense of orientation. Beyond the hippocampus, another group of neurons called grid cells, found in the entorhinal cortex, play a vital role in our sense of space. These cells fire in a repeating grid-like pattern, giving the brain a coordinate system for measuring distance and direction. Working together with place cells, grid cells help us keep track of where we are, how far we've traveled, and which direction we're heading. This partnership forms the foundation of our brain's navigation system, allowing us to move confidently through both familiar and unfamiliar environments. The intricate dance between these neural networks ensures that our internal maps remain accurate and reliable. Cognitive maps do more than guide us through physical space. They also organize our memories and fuel our imagination. Many of our memories are anchored to specific locations, which is why visiting a place can trigger vivid recollections. The brain stores experiences within these spatial frameworks, making it easier to recall events based on where they happened. Furthermore, the same neural systems that help us navigate are used when we imagine new routes, rearrange spaces in our minds, or plan for the future. This overlap between navigation, memory, and imagination shows just how interconnected these processes are, shaping not only how we move but also how we think and remember. Not everyone's sense of direction is the same. Some people seem to have an innate ability to find their way, while others struggle. This variation comes down to differences in experience, attention, and confidence. Regular exploration and practice can strengthen cognitive maps, making navigation easier over time. On the other hand, stress or anxiety can disrupt these systems, causing us to rely more on habits than flexible mapping. Understanding these differences can help us appreciate the complexity of our brain's navigation abilities and encourage us to nurture our own spatial skills through practice and mindful exploration. As we age, the hippocampus becomes more vulnerable to changes and disease, which can affect our ability to navigate and remember. In fact, difficulties with navigation are often among the earliest signs of neurological conditions like Alzheimer's disease. Researchers are studying these changes closely, as early detection of spatial problems could lead to better outcomes. Cognitive maps are essential for daily function, and understanding how they change with age or illness is crucial for supporting brain health and independence throughout life. Cognitive maps are the brain's remarkable tool for navigating both space and memory. Built through specialized neural networks, these maps guide our movements, help us recall experiences, and even allow us to imagine new possibilities. The more we use and challenge our internal maps, the stronger and more detailed they become. By understanding how cognitive maps work, we gain insight into the deep connection between navigation, memory, and identity, revealing just how much our daily lives depend on these hidden brain systems.